Bismillahirrahmanirrahim. Hi everyone, this is the second lecture of our course Statistical Methods for Quality Management, and the title for this lecture is The Role of Statistical Methodology in Quality Management. For this lecture, we're going to look at the role of statistical approach, statistical thinking, variation reduction, statistical methods for quality excellence, statistical inferences on quality characteristics. Okay, this course specifically focuses on statistical theories underpinning in understanding the set of methods or best practices that can be applied to quality management. So, statistical approach emphasizes on the importance of data collection for evidence-based management because decision making cannot be based on mere intuition or judgment. However, raw data collected from the field do not provide the information necessary for quality control or improvement. So, under the field of statistics, it is the science of learning from how data can help you to use the proper methods to collect data, employ the correct analysis, and effectively present the results. But what lies behind statistical approach to solve quality-related problem is the principle that statistical thinking where it will provide the methodology for continuous improvement. Statistical thinking is a philosophy of learning and action, learning how to best acquire data and interpret information while responding to information with appropriate action based on the following principles. Number one, all work occurs in a system of interconnected processes. Secondly, variation exists in all processes. And finally, understanding and reduction variation are the key to success. How work can occur in a system of interconnected processes can be seen in a SIPOC framework. This is an example of how you can document a business process. SIPOC stands for supplier, input, processes, output, and customer. This is a high-level view of a process. It is a process map. It's also a process map where you are not only looking at the steps involved in converting inputs to output, but much earlier, where you identify list of the suppliers associated with each of the inputs of the process. While the inputs includes the resources that are necessary for the process to function properly. Now, the output can be anything from materials, product, services, or even information. Lastly, customers. These are the individuals that will receive the output or will benefit from the processes. Customers are not always external customers. This could also be the co-workers, board of members, or even internal stakeholders. We have discussed this in different types of customers in our previous lecture. Yeah. So this is a diagram that we have looked at also in the earlier lecture, where work occurs in the system of interconnected processes. Yeah. So it means that in a system, it does not necessarily involve only one processes. Definitely it involves a number or couples of processes. The second principle under statistical thinking is variation exists in all processes. There are variations exist in each and every processes. In fact, variation is all around us. Variations are omnipresent. That's what they say, omnipresent. There can never be any system which are 100% exactly of the same dimensional measurements. Yeah. For example, if you were to produce widgets, yeah, so the number of widgets from one production shift cannot be measured of exactly the same measurement. There always be a measurement deviation or variation, even for 0.01 centimeter, for example. Number of calls received, even though through a software help desk, the waiting time for each call will not be the same, as there will be certain number of calls. There will only be certain number of calls that can get through in a certain time. Other examples are the time spent driving to work each day, with many factors that can affect the traffic condition. For example, the number of vehicles on the road, weather condition, and other factors like accident on the road, and others would definitely make your traveling time different from one day to another. Weather forecast is also not 100% accurate. After all, it's only a forecast. Expected time of arrival, ETA, is another obvious example where there'll be cases of delayed arrival. So all activities in industries produce items, product and services, and all these are subject to variability due to variation. The well-known statistician Walter Sheward say that there would be differences between produced items even if produced under presumably the same conditions. Yeah. So no matter how much you will try to control, yeah, so that all the conditions for that particular production will be the same. Yeah, you set up this exactly the same configuration, but however, the produced item is also prone to the problem of variation. Yeah, that is always the case. The third one is understanding and reducing variation as the key to success. So having known that there are variations exist, there is a need to reduce unit-to-unit variation so that customer would come to appreciate the consistency of the product or services that we have produced. Yeah. So when consistency is achieved, there will be less variation, less rework, less off-specification production, and less scrap. And all of this will result in reduced costs, yeah, or less cost. So what are the problems to variation? Variation, number one, will increase inconsistency. Variation leads to defect and non-conformities. Variation has effect on downstream activities, hence make it difficult to detect potential problem early. Variation result in loss due to defects. Variation also cause quality characteristic to get out of specification limits or off target. So all these are the problems with variation. In many cases, this variation will only deter the end result of the production process. So what we need is we need to understand what are these variations, what are the causes of this variation. Yeah. We have looked at during our first lecture where I told you about the US manufacturers started to realize they had incurred considerable loss due to high amount of scraps, yeah, or non-conforming items and reworks that have to be done due to this out of specification items that they have produced, while their Japanese counterparts were reaping profits as a result of reduced scraps and rework, because the Japanese give more attention to reducing variation in their process, therefore reduce variation in their produced item. This was when the quality practitioners started studying variability. And then the notion of quality inversely related to variation was given much attention by the quality practitioners. Quality practitioners started studying variability when they realized it is actually results in the cost of scrap and rework that results in loss to the organization. Much later, Deming came up with his own fundamental principles to quality, which is reduce variation in order to improve quality. Yeah, because we know the very basic idea is that quality inversely related to variation inversely. Therefore, in order to increase quality, you have to reduce variation. Yeah? So, by acknowledging that category is inversely related to variation, again, Deming proposed. Again, reduced variation will help to improve quality. Yeah? So, this is the main idea where people will try as much as possible to understand, yeah, not only to reduce, but before you reduce you should be able to understand where does the variation come from, yeah, then only you can reduce them, and towards the end it will improve the quality of your process and also product or services which has been produced. So this is where quality improvement is defined, yeah. Quality improvement is defined as the reduction of variability in processes and products. An equivalent definition is that quality improvement is the elimination of waste. Yeah. So from our earlier understanding that reducing variation in finished good and product can reduce non-conforming and defective goods or scrap. Yeah. So we would now know that how quality improvement can actually eliminate waste, because by reducing variation, you can reduce scraps and also defective item. Yeah, so this uh, is about reducing variation, and by doing that, you can reduce scraps, you can reduce reworks. Yeah, so all of this will lead to elimination of waste. Yeah, simple as that. Now, there are two types of variation that exist in processes. We know that we must understand variation in order to reduce them. Yeah. So there are two types of variation that can exist in processes. Number one is called common variation. Yeah. In some texts, it is called um, chance variation. Yeah. Variation which caused by common cause of variation or chance cause of variation. So common cause is the type of variation which are normally uncontrollable. Yeah, normally uncontrollable, and due to it is uncontrollable nature, it is actually inherent. Yeah, It is actually inherent. So the presence of common cause of variation is not actually a problem to a process, that the process is still considered to be stable. Yeah, some of the example would be lack of defined standard procedures, which lead to poor uh, working standard or poor working condition, measurement errors, normal wear and tear, computer response time, so on and so forth. Yeah, so this is something that you cannot control. Nothing much you can do about this. So you would say that the existence or the occurrence of common causes of variation is not that will not cause a problem um, to the process. Okay. The second type of variation or second cause of variation is called special causes of variation or assignable causes of variation. Yeah? So these are the causes of variation that will make the process become unstable. These causes of variation are normally controllable and can be identified and also recognized. These are not usually part of your normal process, and it occurs out of your expectation. Yeah, but again, this is something that you can control. Yeah, um, the results of these assignable causes of variation is unstable process. Yeah, it will make your processes not stable. Yeah, so some of the example can be related to some defects in the system or method, machine malfunction, computer crashes, power cut, so on and so forth. Yeah, so these are what you call special or assignable causes of variation, which are actually controllable because it can be identified, and you can actually make things better. You can actually improve or rectify those problems so that it will improve your processes. Yeah. So the occurrence of these assignable causes of variation will lead to unstable process. Huh? So these are again some of the example of assignable causes. Yeah. Improperly adjusted or controlled machines, operator errors, defect of raw material. Yeah. A process operating in the presence of assignable causes is said to be not stable or out of control. Yeah, so this is this is the phrase or the term which you'll be more familiar with throughout this course. Yeah, out of control. Yeah, a process which occur with a process which has the existence or the occurrence of assignable causes is said to be out of control, or we say it is not stable. Yeah, and also the failure to understand these differences can impair variation reduction effort for a system. So, in other words, it means that you must understand the difference between these two types of variation, yeah, so that you know what are the areas for you to rectify, and as a result you can improve your processes. Yeah, you can further improve your processes. So you must understand this variation before you would like to improve the situation altogether. Yeah, so these are some of the example which is have been this is an illustration, yeah, on the sources of variation for a production process. Yeah. So on the input parts, the source of variation can be caused by the raw materials or even the tools being used, yeah, for the processes to take place. The operators, yeah, the men, yeah, you call it human operators, yeah, the workers themselves, the methods that you use for your processes, machines, what sort of machine that you use, environment. Environment is another important aspect of the process. In some cases, the temperature of the factory or the shop floor also plays a very important role in determining the not to say success yet, for a good process to take place. So there will be some mechanism that they will try to come up with the best conducive environment for the processes to take place. And finally, the output. Sources of variation can come in terms of measurement instruments. Once they produce the item, the completed or the finished items is produced, or in other words, you have the completed product, you would like to measure as some sort of quality checking, and the measurement will take place by using certain gadget or certain measuring equipments. So sometimes this instrument, there are problems with these items, measuring equipment. So this is where the source of variation comes. The source of variation from the measurement instruments itself. This measurement equipment, sometimes we have this automatic measuring machine, on which you have to do some configuration. And again, if there are some errors in the configuration of this machine, it can also lead to the problems in the measured items, the measurement of the produced item. Okay. Even more if you are using manual inspection, people themselves using some measuring equipment, like calipers and all that. So some of them, they are not skilled enough, or they are new workers, and they don't perform the measurement correctly, and as a result, it actually give a lot of variations, in the measurement that they have been recorded. Okay. Okay. In identifying source of variation, as we have talked just now, it's very important for us to identify where does the variation come from, and that falls under two types of variation. So in doing so, it is beneficial for us to understand the concept of CTQ. What is CTQ? CTQ is actually critical to quality. So CTQ are the features or characteristics that describe the quality of a product or services. Every product and services has its own characteristic that will describe its quality. So the quality characteristic are called the critical to quality. Not each and every aspect of a product or services is termed or is defined as a critical to quality. We are giving more emphasis to the area which is more important to reflect the quality of certain product or certain services, product or item. So this characteristic of CTQ, sometimes they can become in terms of the physical characteristic, like a length, weight, voltage, viscosity. It and can also come in terms of the sensory. For example, its taste, the appearance. We talk about aesthetic last time. And also color. It can also be in terms of time orientation. For example, its reliability, durability, and serviceability. Okay. So these should be the areas for manufacturers to give more attention so that variation for this CTQ will be reduced to maximum. Okay, so when we talk about reducing variation, we must not forget that as we mentioned just now, variation are omnipresent. Yeah, so omnipresent meaning it is always there. Yeah, so for that reason, you can never eliminate or you can never totally eliminate this variation. Yeah, the most that you can do is to keep it to the minimum. Yeah, so what you need to do is you need to reduce this variation to its minimum. Okay, so how quality can be measured? Okay, we talk about the CTQ. We talk about how quality can be measured through CTQ is quality characteristic. But how do we actually measure those quality characteristics? Yeah. So in doing so, you must understand the fact that whatever quality characteristic that you would like to measure, it has to be measurable. Yeah. Okay. That's very basic. Yeah? If you want to measure something, it has to be measurable. Yeah. So quality can be measured by the characteristic features or attributes of a product. Yeah, we talked about just now how we have three different CTQs, areas of CTQs. Yeah, we have physical, yeah, where we measure length, weight, voltage, yeah, viscosity. This very straightforward. You can easily measure them by using measuring equipment, yeah, uh, measuring some measurement, yeah, for example, rulers and so forth. Yeah, but how do you measure taste, appearance? Yeah, some of those things you need to know very well how you can measure different aspect of your CTQ of your product. Yeah, so this quality can be measured or can be evaluated, number one, in relative to measurements of specifications. Yeah. So, in other words, before you um, um, do the measurements, you must have some sort of guidelines. Yeah, how do you say out of your measurements? How would you say that this is of quality or not of quality? Yeah, so there should be some standards, some measurements saying that certain measurement is of good quality. Certain other measurement is not of good quality. Okay, so that is what you call measurement of specification. Yeah. Um, in most cases, these are what you call dimensional measurement. Yeah, for example, you will be given a guideline of design specification. Yeah, so in this design specification, you will be given the lower specification limit and the upper specification limit. Yeah, the lower specification limit is the smallest allowable measurement. Yeah, and the upper specification limits is the largest allowable measurement. Yeah, and of course, from that you would have the target or nominal values. Yeah, this is what you call desired values. Yeah, and in most cases, this will be the mean values. Okay. Okay, right. These are some of the challenges, yeah, when you try to do record your work from home with people doing work outside and the noise coming into the house, yeah. So it gives some sort of challenges to you. Okay, right. Where were we? measurement of specification. Okay, I was talking about these guidelines. Yeah, so when you do quality measurements, you must know what are the standards, yeah, that you're looking for, so that you know that this measurement are actually of this measurement actually shows you that the product is of good quality or not. Yeah, so we have this measurement of specification. Yeah, or specification measurements where you'll be given the value for the lower specification limit, the smallest allowable, and the upper specification limit, the largest allowable. And normally you would have the nominal values, or you call it mean values. Yeah, you're quite familiar with mean values. Yeah, so if you have certain measurements that you have to fulfill, yeah, so that measurement has to be in between some lower limit and upper limit. Yeah, I'm sure you're quite familiar with the idea of confidence interval. Yeah, confidence interval where we have this um, lower confidence interval, upper confidence interval. Yeah, lower interval, upper interval, and in the middle you have the mean values. Yeah, so this is exactly the same concept. Yeah, that we have for our upper and lower specification limit. Yeah, so I do hope you get the idea of what specification limits is all about. Yeah, right. If you ask me where does this measurement specification come from, yeah, basically it will be given by the R&D department, yeah, or design department. Yeah, they are the one who design the product, so on and so forth. So they will be given the measurements. Yeah, what will be the allowable measurement for certain dimension of the product. Okay. So next is number of defective or non-conforming product. So again, they will give you guideline. Yeah, for example, if you were to inspect uh, the whole production run or production shift, there should be no more than 20%. So there should be no more than 2%, for example. Yeah, for the occurrence of any defective or non-conforming product. So this is something that you have to abide. Yeah, something that you have to adhere, so that you can accept that for a particular production run, it is of good quality. It can produce good quality items. Yeah. Thirdly is the number of defect or non-conformity. Yeah. So please take note the difference between defective and defects. Yeah. And, as well as non-conforming and non-conformity. Yeah, defective and defects. Yeah, defective is basically the adjective of a item. Defects is actually the noun. Yeah, of the item. Yeah, so what I'm trying to say is not all products containing a defect are necessarily defective. Yeah, defective meaning it cannot it cannot function. Yeah, you cannot it cannot perform as it should be. Yeah, for example, if you have car, yeah, if you manufacture a car, there's a defect on the door of the car. Yeah, there's a dent. Yeah, so you say there's a defect, yeah, on the car. Yeah, but you still can drive the car properly, no problem. Yeah, it's just that the defect is occur on the door of the car. So you're saying that that's the defect, but the car is not defective. Yeah, you still can perform. The car you still you can still drive the car. Yeah, so this is what you meant by not necessarily product which contain a defect are defective. Yeah, because there are two different things. Yeah, defective and defect. Yeah, so you can have one defect, but it is still can be categorized as not defective. Yeah, because it still can perform some functions. Yeah, some major functions. Okay, right. So we're going to come back to the definition of defects and defective later on when we do control chart for attributes. Yeah, the second type of control chart that we're going to look at for this particular course. Yeah. Now, the next thing how you can measure the next characteristic, how you can measure quality is based on the waiting time. So waiting time is basically related to services, services being provided or services being rendered to the customers. So we have known that quality need to be measured. So when you do measurements, here comes the question. Um uh, what sort of data that we have in hand? When you measure, you're going to record the measurements that will give you numbers. Numbers, raw numbers are actually data. So when we have data, uh, before we actually move to the next step of analyzing this data, you must understand what sort of data that you have in hand. Is it variable data or is it attribute data? So for quality data, there are two types. There are two major types of quality data. Number one is variable data. Next is attribute data. Yeah. So in general, in statistics, you have actually come across two types of data, which are continuous and discrete data, isn't it? Yeah. So the same applies here, where you will be using the term variable data for continuous data. Yeah. And you'll be using attribute data for discrete data. Yeah. So if you know what is a continuous data, you can come up with the example of what will be quality variable data. What will be the example? Variable data that falls under the category of continuous data. So what is continuous data? Continuous data is data which can take decimal places. Fractions, percentages, so on and so forth. So if you're measuring the quality dimension, for example, length, width, so you will come about numbers with decimal places, isn't it? So that will come that sort of measurements, which is length, weight, height. Those will come under the category of variable quality data. For attribute data, they are discrete data. Discrete data are normally the countable data. How many? They are in terms of counts. Countable numbers. So if you talk about number of conformities, number of defects, so that will be attribute data. That will be the example of attribute data. Okay. So what we have learned so far, we have learned statistical approach to decision making. Okay. Why we use statistical approach in making decision. Come to think about that. Then we have looked at principles of statistical thinking. Okay. What are the three principles? Number one, work occurs in the system of interconnected processes. Work occurs in the system. This is mistake here. The first one should be variation occurs. There's always variation. In produce item. There's always variation. And secondly, the work occurs in the system of interconnected processes. That understanding and reducing variation are actually the key to success. Okay, I think let me correct this. Okay, there is it. Variation exists in all processes. So work occurs in the system of interconnected processes. Understanding and reducing variations are key to success. We also have looked at the definition of quality improvement, which is quality inversely related to variation. We've looked at the sources of variations. Okay. We also look at how quality can be measured, and types of quality data. So that's what we have done so far. So statistical methods reinforce statistical thinking by providing process improvement as the focus for all data collection and analysis. So under statistical thinking, the focus is actually the existence of variation in all processes, and in order to reduce the in order to increase the quality, you should be able to reduce variation in the processes. Okay. uh, Statistical thinking also provides the framework, and it is primarily conceptual, hence it should be applied first. Yeah. So the framework of statistical thinking is the three principles. Yeah. The three principles of quality thinking, statistical quality thinking, which is the three statement that we come up just now. Okay. Variation exists in all product processes. Okay. Processes exist in the interconnection of processes, and reducing and understanding variation is the key to success. Yeah, success here meaning you should be able to improve the quality. Okay, so statistical methods play a very important role in quality improvement because variability can best be described in terms of statistical terms. Yeah, only statistics can teach you how you can understand your variation. Yeah, so application of statistical methods industry to study variation is to systematically eliminate, reduce the variation so as to achieve consistency in performance. Yeah, so these are the key. The key role of statistical methods. Yeah, it shows you the study of variation. It can lead you to the knowledge on how you can eliminate this variation. Yeah, or in fact to reduce this variation, and as the result you can increase the performance. Okay. So statistical methods help in studying variation by representing quality characteristic of variables or product and illustrate the distribution of quality variables in a diagrammatical form. Yeah. So these are some of the areas that you have actually done in statistics. Yeah, at least at the higher level, higher degree. Yeah, you should be able to use this statistical inference. Yeah, the basic statistical inference that you have learned during your degree years. Yeah, so statistical inference can help you to draw conclusion about population from a sample. It can be achieved by estimating population parameter by using sample statistic. Yeah, so it's very important for you to have the idea of sampling distribution. Yeah, that's the major part of statistical, because in real world, sorry, in real uh, in practice, you can never measure the whole of your population. Yeah, if you have produce item, it will be in thousands. Yeah, so you wouldn't be able to do measurements on those um, produce item. Yeah, which is exists in thousands. Yeah, that cannot be done. Yeah, so you have to rely on a sample for quality checking. Yeah, this is where the concept of sampling distribution is very important. Yeah, this knowledge. Yeah. I'm also sure that you have done, enumerative statistic, descriptive statistic, and inferential statistic. Yeah. So the concept of probability and sampling distribution are very crucial in describing variation of quality data. As I mentioned just now, quality data is obtained from samples. Yeah, presumably provide useful information about the quality characteristic of population interest. Yeah, population of interest. So again, sampling is always associated with degree of uncertainty. Yeah, it always have probability of error. Yeah, so this where probability sampling distribution comes into play. Yeah, the knowledge of sampling distribution. Yeah. So again, now if you talk about sampling method, these are some examples of sampling method. These are probability sampling method, uh, on which you have done in one of your core courses, yeah? Sampling study and sampling study and survey design course, one of our core courses. Yeah? So I'm not going to go through this in detail. You should have done that in that particular course. Yeah. So a good sampling plan should select a sample at the lowest cost that will provide the best possible representation of the population. Yeah. In many cases, you would like to collect larger sample size, yeah, but it's not always the case because you have to do it economically. Yeah, you have to also consider the cost that will be incurred if you were to select too large of sample size. Yeah. So that's where when you talk about good sampling, there has to be a balance between cost and the results that you're going to get, on which it should represent, yeah, best represent the population of interest. Yeah. There'll be also cases whereby when you talk about sampling, there'll be sampling error. Yeah. Uh, Sampling error and non sampling error. Okay, so sampling error is actually related to statistical error. Okay, and the non-sampling error is the systematic error. Yeah, so this is something that I would like you to go back and find out. What is an example of sampling error, and what are the example of non-sampling error? Okay, so how do you actually represent it in terms of statistical error? How do you describe, yeah, sampling error in a statistical manner? Yeah, what is it called? Yeah, under statistical term for sampling error. Okay, this is something that I would like you to do. Okay, so other things for you to consider, as I mentioned just now, is the sample size and also the sampling design. Yeah. So these are one of the example, okay, of sampling error, okay, and non-sampling error, okay. It's very interesting. Yeah, it looks simple, but you should have a very good foundation in statistics. As such, you will know the um, the difference between sampling error and non-sampling error. Okay, this is a good area, yeah, for you to have a good reading on it. Yeah, go and find out. Yeah, go back and find out what is the difference between these two. Exactly, you must understand the difference between these two. Okay, now it comes to descriptive statistic, parameter estimation, where this is something that you have done. Yeah, in your if you have done stats method, I'm sure you have done all this. Yeah, and remember you need to apply all this in this course as well. Yeah? If you were to do some reports on your quality characteristic. Yeah, and then the concept of central limit theorem. If simple random sample size n are taken from any population, the probability of distribution of sample mean will be approximately normal as n become large. Yeah. So theoretically, this is how it looks like. Yeah. But as you increase the sample size, your distribution, your data distribution will be more accurate. Yeah, because the dispersion is much less. Yeah, if you have larger sample size, yeah, the accuracy will be much higher. Yeah, if you have larger sample size. In this example, this is just a normal statistic question. Yeah, statistic question. where it can be applied, yeah, in statistical quality control. Okay. I'm sure you have come across this sort of question where it requires the knowledge of your sampling distribution. Yeah, you have the mean values and you have the um, standard deviation and you have a sample size. Yeah, and you will be asked the question on the probability of the dimension exceed certain values. Yeah, so this is actually an example of sampling distribution sort of question. Yeah, so please go back and learn this by heart. Yeah. Under descriptive statistic, you have been introduced to stem and leaf plot, yeah, or box and whiskers plot. You call it box plot, and also histogram. Yeah, so these are the common graphical techniques which has been used in many statistical quality studies. Yeah, uh, as well as measures of location, measures of dispersion. Yeah, the study of uh, um, the average, yeah, values, and also the dispersion. Yeah, these are example of box plot, example of whiskers plot. Yeah, so these are the application of statistical methods, yeah, in quality improvement. We are familiar with descriptive statistic. We are so into inferential statistic. We have done parameter estimation. We have also done a lot of confidence interval and hypothesis testing before this. We're gonna use this again to certain extent, yeah, for this course. Yeah. Um, we're gonna do a bit on acceptance sampling. Yeah. You have done ANOVA, correlation and regression. I'm not going to do this. It will come under, if not your stat data analysis, you come across a lot of regression, yeah, in applied econometric. Design of experiment, yeah, you have a course um, ED, yeah. So you're going to do a lot of design of experiment, yeah, in that course itself. And we have multivariate techniques. We have done techniques like factor analysis, cluster analysis. Yeah. Under marketing, you also have looked at SEM. Yeah. Multidimensional scale. Those are multivariate techniques. Yeah. So our main emphasis for this course will be statistical process control. Yeah. Um, all these are the formulas that quite sure I'm sure you're quite familiar with, yeah. And hypothesis testing is something that you are not unfamiliar with, yeah, meaning to say you have done this before. So just go back and look through your notes, yeah, back again. This is one example, yeah. See, we have the solution here. So this is an example of hypothesis testing question. Yeah, a producer of computer-aided design software uh, received numerous calls for technical support. Tracking software used to monitor response and resolution times. Yeah, so that will be your variable. The company has a service standard of 4 days for the mean resolution time. So your variable will be resolution time, and the mean value is equals to 4. However, the manager technical support has been receiving some complaint of long resolution times during a week. A sample of 44 customer calls resulted in a mean sample of 5.23 and standard deviation of 13.5. Okay, so from end customers, they give their resolution times, and from these 44 customer calls, the mean resolution time is equals to 5.23, yeah, and the standard deviation is 13.5. So even though the sample mean exceeds the 4-day standard, yeah, 4-day standard is the mu, yeah, mu equals to 4. This is X bar. This is S, yeah, because it's come from the sample. Does the manager have sufficient evidence to conclude that mean service time exceeds 4 days? Or is this particular sample simply is a result of sampling error? So this is this question where you have to test the hypothesis. Yeah, the original hypothesis, sorry, the original mean value or the population mean is equals to 4, but the claim which has been made is mean service time exceeds 4 days. So mean service time exceed 4 days will become the null hypothesis. Yeah, remember that. Yeah, this will be the null hypothesis claim which has been made, yeah, against the actual population mean value. Yeah, so if this is your uh, alternative hypothesis, yeah, you should come up with the opposite, yeah, as your null hypothesis. Yeah, so your null hypothesis will be mean response times less than equals to 4. Yeah, so this is the key uh, 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 point that you need to come up from the question. Yeah, if you got this correct, yeah, which you should extract this from the question, and then you should be on the right track. Yeah, and you're going to use T as your test statistic. Yeah, because it applies no sampling distribution. Yeah, this is not a normal distribution because it involves a sample. Yeah, so this is sampling distribution. So from here, you know that you're going to reject null hypothesis if your T is larger than, yeah, is larger than these computed T values. Okay, this is your computed T value, the T statistic larger than the T that you read from the table. Okay, so T n minus 1 and alpha, yeah. So normally you use alpha 0.05, yeah. Your the first degrees of freedom for your T here will be n minus 1, yeah. So your n is 44 just now, yeah. You have 44 calls, so 44 minus 1, that will be your first degree of freedom. Secondly is your degrees of freedom and your alpha, okay. And we compute the value of test statistic by using this formula, and you get a number. Yeah, so this is computed T statistic. Yeah, and this is the T statistic that you read from table. Okay, so because what you have computed is smaller than what you read from the table, so you do not reject the null hypothesis. Therefore, we come up with a conclusion saying that manager finds there's no sufficient statistical evidence that the mean response exceeds 4. Okay, so this is an example of hypothesis testing question. Yeah, please get yourself familiar with this sort of question. Okay, correlation analysis, you've done this. ANOVA, you've done quite a bit of this. Yeah, you can also use this in reporting your in your quality report. Yeah, whenever you want to report the quality characteristic of your data, design of experiment. Okay, this is what I'm going to do. Statistical process control, or you call it SPC, under this course. So SPC is a collection of tools that when used together can result in process stability or variability reduction. Yeah, this is only tools. Yeah, they only give you tools which will help you to find the root cause of your variability problem, and it will help you uh, to monitor, yeah, your quality characteristic over time, yeah, meaning over a period of time, so that you do the needful, whatever you need to do for the process to be stable, and you can also at the same time reduce the variability or variation in your processes. Okay, so these are the 7 major tools under SPC. Yeah, histogram or stem and leaf plot, box plot, check sheet, Pareto chart, cause and effect diagram, defect concentration diagram, scatter diagram, and control chart. Yeah, in major part, we're going to look at control chart. Yeah, we're going to look at 3 major types of control chart in this course. Okay, so that's all for this lecture. So look for the tutorial questions that I'm going to put up in Spectrum based on this lecture. Okay, thank you. Bye-bye.